drying and gravity filtration of an organic material. In the previous video, we illustrated solvent-solvent extraction, where we were able to wash any impurities out using an aqueous base and perform a pre-drying with a brine solution. What we're left with is approximately 50-60 mils of diethyl ether with our organic material dissolved in it. However, diethyl ether and most organic solvents will dissolve a small but meaningful amount of water in the solution, and we have to take that into account and remove it before we do further isolation. To do that, I'm going to transfer my organic material into a Erlenmeyer flask, taking the lid off, draining the solution. I want to make a quantitative transfer, so I'm going to use a small amount of fresh diethyl ether. I'm going to add it to my graduated cylinder. Again, remembering the adage that 2 or 3 rinses is the ideal amount, so I'm just using a pipette, ensuring that all the transfer has been completed. So again, we do have 50 mils of diethyl ether here. We're going to be adding some magnesium sulfate as a drying agent. There's numerous drying agents we use in the laboratory. Magnesium sulfate is just one that I had handy. The laboratory experimental will determine or suggest the appropriate drying agent. Today, magnesium sulfate is the appropriate one. So I unstop her and put in, well, I would say the equivalent for the cookers in the crowd, 2 teaspoons worth of drying agent. 1.5, 2. Stop her and swirl. The drying of the organic solvent isn't immediate. It does take several minutes before any of the water that's present can collect or be absorbed by the magnesium sulfate. So with a stopper, and I prefer cork stoppers over rubber stoppers. Rubber stoppers will absorb organic solvent as well. Cork is much better that way. Keeps the smell down as well. For 2 or 3 minutes, 3 to 5 minutes, swirl periodically. Then the student's common question is, have I added enough drying agent? I'll illustrate that momentarily. So our solution is sat for about 5 minutes in contact with the drying agent. It settles quite nicely. And again, it may be difficult for this to show on the camera. There's a small amount of material that has absorbed the water and clumped effectively. That is illustrative of water being present. All right? Water was present in the organic solvent, it reacted with magnesium sulfate and clumped. What we're looking for is excess drying agent. You can see that the magnesium sulfate, there is some magnesium sulfate that's free flowing. It's very much like fine sand. What that tells us is that all the water has absorbed and there's still excess magnesium sulfate. That tells us that yes, water was present, but there's no longer any free water, because if there was free water, this would continue to clump up and solidify in these little clumps of hydrated magnesium sulfate. After sitting for 4 or 5 minutes, I'm ready to do a filtration. To do that, I'm going to use a powder funnel. I'm going to use my split ring clamp again, very handy. And I need fluted filter paper. Quickly illustrate how to fold fluted filter paper. Student grade filter paper, it's approximately 10 centimeters across. Folded properly, folded in half, quarters, creasing as I go, 8ths, and then 16ths. Done properly. The arc here is about a centimeter and a half. Then I open the filter paper up to the halfway point. Looks a bit like a fan. Then I'm going to use those crease marks to fold and back fold the filter paper accordion style to end up with a wedge of paper. It looks similar to the last one. Right. Again, approximately a centimeter and a half. But you can see because of the accordion folding, it's zigzaggy. Open it up, pop it into the filter, and I'm just about ready to go. Now I'm going to filter directly into another round bottom flask. In the subsequent video I will show you how to remove the solvent using a roto evaporator, but right now I want to separate the dry diethyl ether and organic material away from the drying agent. So ensuring that the spigot is inside the flask, I'm just going to transfer the material. Ensuring that the transfer is quantitative, I'm transferring actually all of the material, not just part of the material. I'm going to rinse my flask with a few mils of diethyl ether. And then I'm going to use a few mils of diethyl ether to rinse the filter paper and the drying agent, just to ensure that any of the organic material that may have been transferred over isn't left behind in the filter. Gravity filtration is the preferred way to filter an organic material. If you use vacuum filtration, the reduced pressure will often lead to excessive evaporation of the solvent and leave your material in a lot of different places, but not where you want it to be. By doing a gravity filtration, the quantitative transfer is very effective, as well as we can filter it directly into our round bottom flask, which fits onto a roto evaporator and allows us to do easy solvent removal.